Okay, so this is a quick video going over what we did in class, talking about functions and domain and range. I'm just going to quickly buzz through this, so if you are gone, you catch up on it. So a function says for every x, which is our input, there is exactly one y, which is our output. So if we look at these, the first we've got some maps. And if we look at the first one, I think if we can compare a yes to a no, you can pretty quickly see which one's which. So if I look at number one, this is my input right here, and this is my output. My input is always my X and my output is always my Y. But if I plug in 0, I get a 0. If I plug in 5, I get 5. If I plug in 6, I get 8. If I plug in 8, I get 8. It doesn't matter what my X is. When I plug it in, I just get one answer. So because of that, it is a function. Now, if I look at number 2, on number 2, if compared to number 1, so you can see a difference. If I plug in 0, I get 6. Okay. But if I plug in 4, I get 0 and I get 6. I get two answers. And if you get more than one answer when you plug in an X, then it is not a function. Or just, no, I didn't. All right. On the next one, if I'm looking at when I plug in 1, I get 9, but I plug in 2, I get 6 and 7. So since I get more than one answer, it is not a function. If I move down here, I can also look at it as ordered pairs. And if I'm looking at here, I plug in 5, I get -4, -3, 6, 7, -4, 2, 10. None of the X's are repeated, so which means that every time I put an X, I just get the one answer. So this is a function. But if I look over here and put a -3 at -7, okay, put in 2, I get 6. But here, if I put in 2, I get 8. So I put in the same number, but I get two answers. That makes it not a function. Okay, so we looked at it at a map. We looked at order pairs. Whoops, and that is not what I meant to do. And the last way you can look at it is through a table. So if I look at this table, I'm putting in 10, 20, 30, 40. Nothing repeats. No matter what I put in, I just get one answer. This is a function. Here, I put in 2 here, but I put in 2 here as well, and I get two different answers. So I put in the same input and got two outputs. That makes it not a function. Over here, for each input, there's just one output, so this is a function. Okay, so we can look at, sorry, it froze on me. Okay, so we can look at it in, this is a yes. We can look at it in the map, in the ordered pairs, in a table. We can also look at it in a graph. And for the graph, we do what's called a vertical line test. So we're going to run a vertical line from left to right. And if it hits the graph more than once, it's not a function. Okay, so if I look over here on number 1, I'm running these vertical lines through my graph, and never does it hit more than once. So that means if it only hits one times wherever I put it, it is a function. I look over here, if I run a vertical line right here, it only hits once. That's fine. But if I scoot that over to the right, it hits 1, 2 times, which makes it not a function. Over here, if I run the vertical line, only hits once. That's good. But if I come in here, oh my gosh, it's hitting 1, 2, 3 times. Not a function. If I look at number 4, running the vertical line left to right, only hitting one time. Yes, it's a function. Over here with the circle, come over here, it hits one time. That's good. But if I scoot it over, it hits 2 times. If it hits more than once, not a function. Over here on number 6, it's a little deceiving because you're thinking, okay, I'm running my vertical line. Oh, I don't want to use red. I'm running my vertical line, all good. And then we get to here. And it's confusing because it appears that it hits twice, but we need to be careful. This one is an open circle, so it means everything up to but not including. So there's actually not a point there. But here, because there's a closed circle, there is a point. So even though it looks like it's twice, it's deceiving because this is not a point, so it only hits once. So yes, it is a function. All right, let's go over and look at number 7. So my screen totally glitches out again. Okay, on number 7, we got the same situation. I run that vertical line, But here it's not an issue because we have an open circle and a closed circle, which means it only occurs once. So that's okay. So yes, it's a function. Same thing over here. So we're good to go. All right, if we look at number 8 and we're running our vertical line, here it occurs once, no big deal. But here it goes through 2 points on the same vertical line, not a function. Okay. Oh my gosh. My computer is not cooperating. Okay, so if I come over here, run the vertical line, 1 point, 1 point, 1 point, 1 point, 1 point. It's always 1. So that's yes. Okay, so after we talked about functions, then we talked about domain and range. And domain is the set of all x values. We read it off of the x-axis and we read it from left to right. The range is the set of all y values and we read it off of the y-axis from bottom to top. So if we're looking at it, the first way we can look at it is in an ordered pair, and the domain is the x values. And since these are not connected, they're just single dots, we're going to use this funky bracket and we're going to write them in order. But when you write them, you got to write them in order from least to greatest. So my smallest one is -8. I've got -8 again, but you don't need to repeat it. Once it's on there, we're good. Then I have a -6 and a -3, and that should do it. Oh, a +6, excuse me. And then we close our bracket. For the range, do the same thing, but now we got to do the y values. And again, they have to be from least to greatest. So we have -7, and then -2, and then 4, and 6, and 7, and we're done. Same thing on number 2. Okay. But now let's look at it when we're on graph. The domain and range on a graph is trying to make a picture frame, and the X's are going to give you the vertical lines left and right, and the Y's are going to give you the horizontal lines bottom to top. Okay, so if I look at this, my X, my farthest X, I'm going to read it off the X-axis, reading it left to right. So the leftmost point is -5, and I'm reading off the X-axis left to right because it is domain. Okay, now it's an open circle there, and we're going to write an interval notation. So open circles means parentheses, and it goes all the way to this closed dot, which is at +5, and we're going to put a bracket. If we're not sure, we're comparing parentheses to brackets. This is going to take open circles. This is going to be closed circles. Dashed lines, solid lines, infinities are always parentheses. Okay, now let's do the top and bottom. But we got to go bottom to top. So the high, oh, I didn't want to do green. Okay, so the lowest value is right here, which is a little confusing because we have an open circle, a solid line, a closed dot. It doesn't exist over here on the left, but it does exist on the right. So since it exists, we need to have the bracket, and the lowest point is -2, and the top point is +2, and it's a solid line, so it's a bracket. So we just kind of created a box around our graph, and that's what the domain and range does. The domain is left to right, the range is bottom to top. You read the domain off the X, you read the range off the Y. All right, the next one, the domain, the leftmost value is -4, the rightmost value is 3, but it's an open circle, so we have a parentheses. For the range, the bottom is -5 and the top, oh, but it's a parentheses. So because it's an open circle, the top is 5. So it's a parentheses. On the next page, the domain. The domain is left to right and we've got arrows. So even though it slowly is getting wider. So left and right, it's going to cover everything. So it's -infinity to infinity. The range is going to continue to go up and down indefinitely. So it's going to be -infinity to infinity. Okay, a little racing from last time. And number 6, your domain is your left and right, or we read left to right off the X-axis. But on this one, notice number 5, it's all connected, but 6 is at separate points. So on 6, we have to write this curly brackets or those wavy brackets and list the X values from left to right. So we've got -3, -2. I'm reading off the X-axis because it is the domain, and 2 and 5. And now we're going to do the same thing with the range. We got to read the y values, bottom to top, -5, 0. There's 2 points at 1, but we only have to list it once. And then we have 4. Now I did the squiggly brackets on those because it was not connected. Everything else, when it's connected, you have the intervals. So on this one, the domain left to right, so it goes from -2 to 2. The range bottom to top goes from 1 to 5. Over here, the domain, it is keep getting wider, so the domain is everything, negative infinity to infinity, but the range is not, because it starts here at 0, then continues up to infinity. All right. Number 9, the domain goes left to right, so it's negative infinity to infinity. The range, though, the range is just at this one y value. It's just at 3. And when it's a single number, we put the squirrely brackets. So when it's a list of numbers or just a single one, we put those wavy brackets. Otherwise, it's going to get the parentheses and the brackets. Okay, the last thing we did is evaluate functions. And I put this on here not because it's evaluating, but make sure you understand it. This right here is function notation. And we read this as f of -2, and it equals -14. But whatever is in here is our x, and this is our y value. So we know our ordered pair is -2, 14. So I'm going to go to -2, and then 14 is way off my graph. So I'm going to put that, oh, except it's -14. So now I can plot the point -2 down here. Okay, this point here, this is my x, this is my y. So when I plot it, I'm plotting the point 1, -2. So the point 1, -2 is right here. Okay, you can plot the other points. But now, understanding that it's an x and a y, what these problems are doing, and this is what most of your work is on, this is the x value, and it says, tell me what y equals. I want to know. So you're going to find -1 on the x. Well, that's right here. It just happens to be right on my graph. And my graph is not at 0 for y right there. Let's try another example. It might make more sense. I'm going to go to 1 on my x value, which is right here. I have to go down to my graph, and now I have to see where that is on the y. Well, that is at -1. Okay, what about 3? I'm going to go 1, 2, 3, which is right here. Go up to my graph, read where that is the y. It's on 2. Now, this last question is different, but this question says, I want to know what my x is when my y is -4. Okay, so now we're just going to go backwards to what we did. -4, 1, 2, 3, 4 is right here. And I go across and I go up, and it's right here, which is 1, 2, 3, 4, also at -4. So this one equals, oops, it's not y, x equals -4. All right. Let's try this again. F of 4, 1, 2, 3, 4 is right here. I go up, I read it, +4. F of 8, right here, go up, read the y, 6. F of -6, I go up, I read the y, and it is at 5. Very straightforward. The other one that's different is this is the x is unknown, and this is our y. So just go backwards from what we did. So if y is 2, that's right here what the x is. Well, it's just right there on the axis. So y has to, or excuse, oh, I did it again. So x has to be 0. Okay. Don't worry about this middle one because we're not going to have one like that on the quiz of the test. But if we're looking at at the first one, g of -4, this just means use the g graph. So I'm going to go to -4. I go up. I see it's at +4. But look what happens over here. I want 8. So 6, 7, 8. I go up. That's not going to hit F. If it's not going to hit F, there's no answer. And if there's no answer, we put undefined. Okay. Let's do one more. H of -1 is right here. Go down, and it's going to be at -3. I can do another one too. H of 2. Oh, this is a good one. H of 2. I go down to H. and there's an open circle. Open circle means there isn't a point, which means it is undefined. Okay, you can practice this more with your Delta Math assignment.